Day, grade 10s. Welcome to our revision session for paper 1, question 1 with KHUMALO.M. I hope you are preparing very well for this examination that you are going to write here in Tswana South or any place you are in Gauteng. Now, we are going to take a look at question 1 and how our question paper is structured. So now, what I want you to look at and what I want you to be aware of for the paper of Tuesday is now the structure of paper 1. The structure of paper 1 in grade 10, it consists of 3 questions, which is question 1, atmosphere, out of 60 marks, with question 2 out of 60 marks, which is geomorphology, and question 3 out of 30 marks, which is geographical skills and techniques. Now you can see grade 10s that 1.1 it is 7 or 8 marks, 1.2 it's 7 or 8 marks. Those are your questions like match column A with column B, choose the correct word from the brackets, define matching concepts, and all of those questions. Then we've got 1.3 out of 15 marks, 1.4 out of 15 marks, 1.5 out of 15 marks in the same manner in question 2. And then question 3, you can see there our map skills and calculation, they consist of 10 marks. Our map interpretation that is associated with topic 1 and topic 2 will consist of 12 marks. And our last question there in 3.3 is GIS, which is out of 8 marks. Now that question paper grade 10, it consists of 150 marks. You are going to write it for 3 hours. So here in Tswana South or here in Gauteng, we always say that spend 55 minutes in each question or spend 50 minutes in each question. Then you'll remain with 30 minutes to read throughout your paper, to check your answers, to verify your answers before you submit. Without a wastage of time, let's look at that we did this year. Now, question 1 is based on atmosphere, the work that you've done in term 1. Now, you can see topic 1 there in atmosphere, it was the composition and the structure of the atmosphere. Question 2, topic 2, sorry, it is the heating of the atmosphere. Topic 3 is the moisture in the atmosphere, and the last topic in atmosphere, it is the synoptic weather maps. Now, on the structure of the atmosphere, under the atmosphere, the first thing that you do, why is the atmosphere important? That is a question that you should ask yourself as you are preparing for your examination that you're going to write Tuesday or any other day that you're writing around Gauteng. Now, the importance of the atmosphere, it is the source of climate and weather for the earth. It shields us from harmful ultraviolet rays. You have done that. It moderates the temperatures of the earth. Water vapor gives us rain and moisture, and then it provides us with gases that are essential or that we need for life. The word essential, it means that it is important. Now, another thing that I want you to know, grade 10s, will be what is a composition? Now, when we talk about the composition of the atmosphere, now it is what the atmosphere is made of. So when we talk of composition, it's what the atmosphere is made of. The atmosphere, the air is in the atmosphere consists of mixtures of gases. What are those gases? We've got permanent gases, we've got variable gases, we've got non-gases and pollutants. Now the permanent gases will be your nitrogen and your oxygen. Then variable gases is argon, water vapor, ozone, and greenhouse gases. They fall under the variable gases that compose or that formulate what we call the atmosphere. And then we've got non-gases such as dust, salt, and smoke particles. And then we have pollutants. Now pollutants are such as sulfur dioxide and methane. Now remember, the most important gases that we talk about when we talk of the composition of the atmosphere will be the 78% of nitrogen on the atmosphere, the 21% of oxygen on the atmosphere, and the other or the rest, like argon, they make 1% of the atmosphere. Then remember, we just spoke about the composition of the atmosphere. Now we come to the structure of the atmosphere. Now composition, remember I said, what is it made of? What is the atmosphere made of? Then now we are looking at the structure. Now the structure, it will be, how does the atmosphere look like? So now, what is the structure of the atmosphere? We know that the atmosphere is in layers from 0 kilometers from the Earth's surface to 15 kilometers up there in the sky. We have the troposphere, where at 15 kilometers we have the tropopause. Then between 15 and 50 kilometers we have the stratosphere, and there at 50 kilometers we have the stratopause. Then from between 50 and 90 we've got what is called the mesosphere, and at 90 kilometers we have the mesopause. Then high above 90 kilometers, then we are going to get the thermosphere. So the atmosphere is formulated by layers. So we have the composition and we have the structure of the atmosphere. Now, I believe you know that when we talk about the composition, we are talking about the gases that make up the atmosphere, and the structure, we are talking about the layers that make up the atmosphere. That is very important, grade 11, in preparation of your examination. Now, another topic that you learned in term 1, it was ozone layer. So here is a summary that I've done for you in terms of ozone layer. Now, what is ozone layer? Ozone is a gas, so it forms a layer in the stratosphere. What is the function of that layer? Is to absorb the ultraviolet radiation. So now, the ozone layer, it is an ozone gas that forms layers where? In the stratosphere. And what is the function of this ozone layer? Is to absorb ultraviolet radiation, these harmful rays that come from the sun. And now, the effect, then we come to how can ozone depletion be reduced? We must know causes of ozone depletion and effects of ozone depletion. But now we have to start with ozone depletion. Now, when there is a hole on the ozone layer, we call it the ozone depletion. When it's destroyed, you call it ozone depletion. So what causes ozone depletion? We talk of chemicals and the CFCs. Remember the CFCs, the chlorofluorocarbons. Now, those are the gases, or those are the elements that causes ozone depletion. Now, what are the effects of ozone depletion? Now, when we have what we call ozone depletion, remember your teacher has taught you that we can get skin cancer, eye cataracts, or photosynthesis will be disrupted. And then how can we solve this problem, grade 10s? It's how can we reduce it? Now we can the CFCs banned limit traveling by cars, so we can ban chemicals or products that we are using that are not ozone friendly. Now, limit traveling by cars, saying for example people taking public transport but then driving their own cars, because that contributes to ozone depletion. Avoid pesticides and fertilizers. We avoid pesticides. Pesticides is those chemicals that they spray just to kill the pests, and then fertilizers, they are used for the nutrients of the soil, which they are also an impact of ozone depletion. Then there are some concepts that I want you to be well aware of before we can come to what we call the heating of the atmosphere. Now we've got insulation. Remember insulation, the word insulation is an abbreviation, grade 10s. Now what does insulation stands for? It stands for incoming solar radiation. But nevertheless, that is not the definition. That is writing insulation in full. But now insulation, how does Khumalo explain insulation? I will say that now is the energy from the sun that in a form of heat and light. The energy from the sun in a form of heat and light. But here I have given you that it is rays entering the atmosphere from the sun. It's still the same thing. Then we've got another concept, which is reflection. When we talk about reflection in geography, we are talking about the sun rays strike a surface and are redirected back 180 degrees back. So when the sun rays, they bounce back, that is reflection. And then we talk of scattering. Sun rays are redirected randomly into the atmosphere, so they will scatter. You know what is to scatter, grade 10? If I say I take a plastic of marbles and I bust open it, they will scatter, they will go into different direction. That is what we are talking about. Then we talk of absorption, when heat is taken up by gases or water vapor. To absorb, you know what is to absorb? To absorb, it is when heat is taken up by gases or water vapor. Then we've got radiation. Radiation is the earth radiates heat into the atmosphere. So it's the heat that is radiated from the atmosphere, the heat that is radiated into the atmosphere. Then we've got the process of conduction, where the lower parts of the atmosphere are warmed because of what? They are in contact with the warm earth. So the lower parts of the atmosphere, they become warmed because of what, grade 10s? They are in contact with the warm earth. Then we've got convection. The process of convection is when air is heated and it rises. Heat is transferred higher into the atmosphere. So now this air that is heated, it will start to rise and the heat will be transferred to higher into the atmosphere. Then you looked at the heating of the atmosphere. Now, the processes that are associated with the atmosphere, with the heating of the atmosphere, are those processes that we talked about, which is absorption, scattering, and reflection. So here is the percentages that we can look at: the reflected, the amount of insulation reflected by the clouds, reflected by atmospheric gases and dust. They are reflected by the surface. And then those that are in blue, they are absorbed by the atmosphere, clouds, water vapor. So there in my diagram, 23% is absorbed by the atmosphere, by clouds and water vapor, such as and other gases and other things like gases and dust. And then 46% it is absorbed by the earth's surface, and the rest of it is scattered. You can see the grade 10s. Then we now, what are the factors that affect temperature? This takes you back to your social sciences, the geography part in grade 8, where you learned about the latitude. Now, the definition of a latitude is the measurement of degree in degrees from north to south of the equator. Now that will be from east to west, because it's north and south of the equator, not of the Greenwich meridian, but of the equator. Why is the equator hotter than the poles? The sun rays are more directed and are concentrated on the smaller area than the poles. So now when the sun hits in 100% form, it hits directly to the equator. So that is why we are going to get high insulation heat next to the what? Next to the equator. It's very important for you to understand that, because now that one, it explains to us how now this air is going to be transferred across the global, so that we can have a well-maintained global climate. Then we continue, we look at altitude. Now, what is the definition of altitude? Remember in grade 8, you have also learned about altitude, the height above the sea levels. Now, we say here, air temperature decreases with altitude. So the higher you go, the colder it becomes. Just look at the picture that I've put for you of mountain Kilimanjaro. Now you can see that from the bottom, or from the foot of the mountain Kilimanjaro, there is no ice or snow there. But when you're on top of the mountain Kilimanjaro, you start to see that it is covered by ice. Now, what does that mean, grade 10? It means the higher you go, the colder it becomes. The higher you go, the colder it becomes. Yes, you can continue saying it. The higher you go, the colder it becomes. That is the effect of altitude. Not latitude, but altitude. Now, grade 10s, remember that now we no longer have that paper that is having 75 marks of Mapwork. Now, we have integrated. What is to integrate? Is to join the topics of topic 1 and chapter 2, which is geomorphology, and try to apply them into what? Into Mapwork. Now, this is an application of topographic maps. At which of the locations, A or at B, will it be warmer? Give evidence from the map to support your answer. So the most important things that you can, that is the type of a question that you may be asked in terms of the topographic map in question 3.3, where you are doing interpretation. You must take note of the following on the map. A is located on the valley at the benchmark that is given a height of 227.8 meters, and B is located on the and then that B is located where? It is located on a mountain, for example, and B, the contour lines. We can see the mountain through the contour lines there at a trig station with the height 1028.7 meters. Now, it will therefore be warmer at A. So, therefore, it's going to be warmer at A, and it will be colder at B. What principle are we using here? We are using the principle of altitude. The higher you go, the colder it becomes. So that B, it's a mountain. So as we go up, the height is increasing. You can see the height is increasing. So the higher we go, the colder it becomes. The lower you go, the warmer it becomes. It is therefore be colder at B, there is an increase in height from A to B. So I always say to my learners that if you, in geography, if you write an answer and you don't have a reason why you are saying that is the answer, then you have written matramputa voroso, something that is out of order. So you must always have reasons why you are saying the answer is B or the answer is A. Just like as I'm giving here, great turns, you can see that now I am saying therefore at B it will be colder. What is the reason? There is an increase in what? In height. So the higher I go, the colder it becomes. So at B it will be colder, then at A it becomes warmer. So you must take note of things like that. They may be asked in the Tuesday's paper or in the paper that you're writing. I don't know other dates in Gauteng, but in Tshwane South it will be. Now, another thing that you have to take note of is the ocean currents. Remember, you've learned about the ocean current, the cold ocean currents, lower water and air temperatures. The warm ocean currents, rise water, the water rise, there's a rise water and air temperatures. Now, the east coast has higher temperatures than the west coast in South Africa. Consult key on the map of South Africa. So now you will know that this side we are having on the east coast, we are having what we call the warm Mozambique ocean current, and that side of the west coast of South Africa we have the cold Benguela ocean current. So obviously if it's the cold Benguela ocean current here on the western coast, in the west coast, we expect temperatures that are lower and that are colder. And then this side on the east coast of South Africa where we have the Indian Ocean, we have the warm Mozambique current. So we expect the temperatures to be a much warmer than the west coast. Now, another effect that we look at in terms of heating of the atmosphere, it is the distance from the ocean. So the oceans, they heat up and cool down more slowly than the land. So for the ocean to heat up, it takes time. For the ocean to cool down, it takes time. So the land heats up faster than the ocean, and the land, it cools down faster than the ocean. The coastal areas are cooler than the inland areas during the day. So during the day, now the coastal areas will be a bit cooler, while the inland, it is very warmer during the day. But during the night, that is vice versa. The coastal areas become warmer inland, and then the inland it becomes warmer than the inland during the night. That is what that diagram that I've placed there, it explains to you. It's very important to take up this because you'll be doing it in grade 11 and 12 as you go up. Now, another nice topic that you've done, grade 10s, it will be what we call the greenhouse effect. What is the greenhouse effect, grade 10? The process by which certain gases in the atmosphere absorb the long wave radiation and return some of its radiation back to the earth. This increases the air temperature of the atmosphere. So that is the greenhouse effect. So it's a process where the certain gases of the atmosphere absorb long wave. So these gases, they absorb heat and they lead into what? And what are those gases? We call them the greenhouse gases. What are the examples of the greenhouse gases? That is carbon dioxide, nitrous oxide, the methane, water vapor, and CFC, which is the chlorofluorocarbons. And then now, what are the impacts of greenhouse effect on people? Now, you can be asked maybe in a paragraph question and say in a paragraph approximately 8 lines, describe the impact of greenhouse gases on people or on the environment. Or they can even give you and say on people and the environment. Now, the impact on people, the land will be reduced, flooded cities, we will have homeless, people will be homeless, there will be food security, and people and diseases such as malaria. And then now you can see that on the people, there are some that are positive, there are some that are negative. Food security is a positive one because people are going to have they will have availability of nutritious food that you've done in grade 9 in term 4. Now, the impact of greenhouse effect on the environment: flooding. It may lead to rise in salt levels, the beach erosion, the acid rain, and glaciers melt. Now, what is glacier? Moving ice. Now we know that as these greenhouse gases continue to have a greenhouse effect on our atmosphere, then we are going to get a process or a geographical condition or a climatological phenomenon which is known as global warming. What is global warming? An increase in average temperatures of the Earth's atmosphere. So when there is an increase in the average temperatures of the Earth's atmosphere, then we call it global warming. Now, what causes global warming? Human activities, not women, sorry. Women will beat me when they hear this video. Now, human activities increase in greenhouse effect. So the human activities, so people, the things that people do, they increase this greenhouse effect, such as spraying deodorant, such as going for braais, such as burning fossil fuels, such as industrial and manufacturing companies. They lead into more greenhouse gas effect. More fossil fuels burned, and deforestation, which is cutting down of trees. Now, what are the consequences? Now, before we can go to the consequences, the impact on Africa's climate, which is climate change. Now, shrinking tropical glaciers, expanding deserts, so deserts we will have more desert, and the deserts will be expanding. Drought and famine. Famine is hunger. Drought, it is a long period of time without water. Higher temperatures, as food security is threatened, then we are going to get food insecurity, not food security. We are going to get food insecurity, where people have lack of access to nutritious food. And then what are the consequences of global warming? Now, when this global warming is happening in grade 10, what are the consequences? Because some of you will say the tlamrao. What are the tlamraos of global warming? Now, the consequences of global warming will be melting of snow and ice. There will be rising sea levels. Now, you know that once there is a rise in sea levels, there will be floods. Extreme weather, desertification, and climate change will be our consequences. But now, what can we do? Because now here is a problem. As geographers, we come up with solutions. So what can be done? We need to regulate the emission of greenhouse gases, use solar and wind power than coal-generated electricity. We use sustainable transport, which is like public transport, such as your taxis, your trains, so that we have less cars on the road. Use energy efficiently, regular discussion and strategies. So that is a summary on global warming. Then we move to the moisture in the atmosphere. Now, also this one, I have some concepts that I want you to know, grade 10s. Now, the first concept will be evaporation. Evaporation, a process whereby water is converted to gas. So when the water changes its phase from liquid to gas, that is through the process of evaporation. Dew point, that means it's the temperature at which condensation of water vapor takes place. So it's the minimum temperature there. Condensation, when water vapor in the atmosphere cools down and changes to water droplets, that is condensation. Precipitation, a falling of water or ice from a cloud to the ground. Then humidity has to do with moisture, the amount of water vapor in the atmosphere, in the air, not in the atmosphere, okay, we can say in the air. Then the relative humidity, we are looking at the amount of water vapor in the air compared to how much it can contain. Then we've got clouds, minutes water, it's a minute water droplets and ice crystals that are floating in the atmosphere. Then now, this one is one of the important things, grade 12, the grade 10s, that I want you to know. Sorry, I'm always referring to grade 12s. I'm always dealing with the grade 12s, so I'll get used to grade 10s. Now, here you see there are different types of clouds that you have learned. We've got the cirrus, their characteristics. we've got the nimbostratus, their characteristics. You've got the stratus, their characteristics. The cumulonimbus clouds, their characteristics. I always call them the tall cumulonimbus so that I can remember when I see the diagram, and the cumulus also with the stratus and alto cumulus. Now, this is diagram. You must know it. You must study it, grade 10s, and then understand what is going on here. Then we've got types of rainfall. Remember, once the clouds have been formed, then we are going to have type of rainfall. So we've got the relief rainfall, or which is called an orographic rainfall. So you can say relief, or you can call it the orographic. Now, air rises on the windward side of the mountain, air cools and condenses, cloud form, leeward side of the mountain remains dry and cold, the rain shadow. Then we've got conventional rainfall, sun heats air, air rises and cools, cumulonimbus clouds form, thunderstorms occurs during summer in the interior of South Africa. So those are the characteristics of these three types of rainfall. The last one is the cyclonic, which is known as the frontal rainfall, which you'll have to take it to grade 10, 11 and 12 also. Now, the characteristics of frontal rainfall: warm air rises above cold air at front, rising air cools to dew point, condenses, clouds form, occurs in the Western Cape during winter. So that is the type of rainfall. Now, then we look at how to interpret synoptic weather maps. Now we start with the weather station model. We are going to find a diagram like this. Now this circle represents cloud cover. This line, long line, it represents the wind direction. The smaller lines there, they represent the wind speed, which is measured in knots. A shorter line there, it means it's 5 knots. A longer line, it is 10 knots. So now, if I can ask you very fast, grade 10s, what is the wind speed there in that weather station? Then you will say to me that that is 25 knots. Then that air, that maximum or the highest temperature, we call it the air temperature. The lower temperature, the minimum temperature, we call it the dew point temperature. And this symbol that is found here is precipitation. Now we've got different types of precipitation and different types of cloud cover. So you must know these because those are the main ones that we use in the examination. Then going to the actual synoptic weather map, now you look at things like the coastal low pressure air, high pressure air descends and it is anti-clockwise. The low pressure air rises clockwise. There is our South Atlantic high pressure, that is a weather station at weather at Port Elizabeth. Then we've got a high pressure cell there, which is the South Indian high pressure cell. That one is distance between one isobar to the other isobar. So the difference between these two isobars is known as an isobaric interval. And then that line, we call it an isobar line joining places of equal pressure on a synoptic weather map. And then that is a symbol of a tropical cyclone, clockwise movement of the low pressure, and we know our isobars that we've talked about. Then here are some questions that they can ask you, such as in global warming. This is a new type of a question, grade 10, that I want to teach you because you've never done this type of a question in previous grade. This one, we call it the infographic. An infographic, it will be made up of different sources, such as here's a graph and a cartoon there. Here we've got different diagrams there that's showing transport, electricity generation, industry and agriculture, and a little text there. So all this, we call it an infographic at once. So you get questions like define or what is global warming, does the graph, so all these questions. And one of the questions that you are going to meet up is the question that you have started in social sciences, which is a paragraph question. In a paragraph, approximately 8 lines, discuss these consequences. So that's where you discuss your consequences in terms of the process of global warming. Now that is as an example of one of the questions. The other question, that is the synoptic weather map. You can see here the questions in synoptic weather map. You are going to pause this video, you're going to write and answer the 2 questions, and then the rest of the questions you will find from your teachers or from the or just find it on our group chats. Ask your teachers about the district group chats, and then they will send them to you to study. This is from me, KHUMALO.M, the Geography Sangoma in Tshwane South. Have a lovely day.